I'm going to be deriving some equations. You don't need to know how to derive them. I'm not going to ask you that on a test. So the first half of this lesson is more because I prefer to show you where stuff comes from. I don't like to just have you take things on blind faith. Review of kinematics, the motion equations. Acceleration is defined as a change in velocity over a time interval. In math notation, we use an A for acceleration, and our symbol for change in is a delta, and so it's delta V over delta T. Once we've defined acceleration, everything else kind of pops out of there. Oh, and Gabe, since change in anything is equal to what? Final minus initial. We often wrote it this way last year. A equals VF minus VI. And then we got sloppy. We dropped the delta in front of the T because time was always a change in, because the only way that you can measure time is to measure the final and the like start and stop a stopwatch. And so, Sam, we got lazy. I am going to emphasize a little bit more that we do have vectors this year, though. This was your first, quote, real equation in Physics 11, except we never wrote it that way. We got the VF by itself. The one that's on your formula sheet is VF equals VI plus AT, times by T plus the VI over to get the VF by itself. That one probably you may even still have had memorized from last year because we used it a lot. Some assumptions here. This assumes uniform or unchanging acceleration. We don't have the math skills, Ben, to deal with a changing acceleration. That needs calculus. Where might there be a changing acceleration? Rocket science. When they launch the space shuttle, the rocket is putting out a force. Who remembers from Physics 11 last year, F equals what? MA. Well, as the fuel burns on the space shuttle, what happens to its mass? It gets smaller, but the force doesn't change, and so if M gets smaller, A has to get bigger. You may have heard, Jacob, astronauts talk about how when they're launching the space shuttle or the Soyuz rockets, they're pulling 7 or 8 Gs, but then you've watched it on TV, and when they're leaving the launch platform, it looks pretty slow. They're not pulling the Gs initially when they leave the launch platform. They're pulling those Gs right before they shut off the engine, when the force is at its still the same, but the mass is at its minimum. Hashtag nerd trivia. So if you have a changing acceleration, it gets ugly. We will look at one special changing acceleration case this year, and that's when you're moving in a circle, and you're going to see the complexity jumps way up. If we have uniform acceleration, we can find average speed. Technically, the symbol for V average is this. The symbol for average is a bar. I tend not to use that because when I shrink your fonts down, that and that look really, really similar. It's hard to tell the difference. So I tend to use a subscript of avg, which isn't correct, but it's easier to read if I'm trying to save paper. How do we find an average? If Lorenzo has $30 and I have $20, what do we average between us? Ooh. Okay, we'll go easier numbers. If Lorenzo has $20 and I have $10, what do we average between us? Ben,
15.
How can you take a 20 and a 10, do some math, and get 15 as an answer?
Add both and just get the correct value.
I think this is the second equation on your formula sheet. We'll almost never use it, but we need it to derive the rest of the equations. However, I do think on the ultimate review, that big review that I gave you, I think there is one question where you do have to pull this thing out. I think. I get distance and displacement mixed up all the time. Really, this should be displacement. I finally fixed it in my handout this morning. and it's average velocity times time. In other words, don't write this down, but in my brain, I'm thinking that. Don't write that down, though. Oh, Kimia, what's average velocity? Over? So I replaced it with that to get this equation. This is what we're going to play around with, this equation here. Not only that, what does VF equal? VI plus?
Acceleration.
Just use letters.
AT.
So VF equals what?
VI plus AT.
I'm going to do this again for a reason. What does VF equal?
VI plus AT.
So wherever I see a VF, what can I replace it with?
VI plus AT.
I'm going to do that right there. And I'm going to get D equals VI plus AT, and then that second VI drops down like a domino, all over 2 times T. Algebraically, what's x plus x? 2x. My whole morning class said x squared, and I had to freak out on them. So 2x. What's VI plus VI? So I can rewrite this as 2VI plus plus AT, and then a T outside the brackets, all over 2. I'm going to multiply that T outside the brackets onto everything inside the brackets. If you have Mr. Rocca, I think he calls it front door bomber. The fancy proper term is distribution. I'm going to get 2 VIT plus A TT, but what's a better way to write TT? T squared. And that is all over 2. By the way, I'm going to bring all the vector signs in on my last line. If I write them in on these stages, it gets really cluttered and yucky, but this is a vector, this is a vector, and this is a... I'll bring it all in at the end. Kimia, what's this divided by? What's this divided by? I can break it up. I can actually write it as 2 VIT over 2 plus AT squared over 2. And usually when I write this line, kids kind of, I see where we're going with this. Because what can I do with these two 2's? And I get D equals VIT plus, although we never wrote AT squared over 2. What did we write last year typically? So this can go in the box right here. You don't need to know how to derive this, but here is our displacement equation. VIT plus 1/2 AT squared. Ta-da! I thought I warned. So we have VF equals VI plus AT, which came from our just defining what acceleration was. Then we said, well, average velocity is add them up and divide by 2. And we said distance is velocity, average velocity times time. We're able to generate this. Let's start over again. Again, distance, technically this should be displacement, is defined as average velocity times time. This time, I got T by itself. Justin, what does T equal? So wherever I see a T, what can I replace it with? Yeah. So I'm going to do that right there. And I'm going to get this. D equals, so that first big bracket has average, VI plus VF over 2, or VF plus VI over 2. And I'll replace the T with VF minus VI over A. Most of you suck at fractions, and it's not your fault. The curriculum does not do a good job. We are multiplying fractions together. Multiplying fractions is the easiest of all the fraction operations. It's top times top, bottom times bottom. On the bottom, I have a 2 times an A. How do I write 2 times A? So if I do that, I'll get a D equals, on the bottom, I'll get a 2A. On the top, I have VF plus VI, VF minus VI. You might recognize that from your factoring days as difference of squares. If I FOIL this out, I'll get this. D equals all over 2A. There's going to be a VF squared. And if I multiply the last two terms together, I'll have a positive times a negative, which is a, and I have VI times VI, so I'll have a minus VI squared. Now, if I multiply these two middle terms together, I'll get positive VI VF. If I multiply the outer terms together, I'll get negative VI VF. You know what positive VI VF minus VI VF is? 0. Hey, some of you might recall this equation. Oh, but then we got the VF by itself. How would I get the VF by itself? What will I do with this 2A? And I'll get 2AD. So cross that out, put a little 2AD right there. And then I'd plus the VI squared over, and you might recall this one from last year, Danielle. VF squared equals VI squared plus 2AD. I was careful to add vector notation to this equation. This one here is a bit of a tricky equation. Because you're squaring, you often get a scalar answer and have to add the vector after the fact, and we're going to run into that a little bit. In fact, I do know a couple of high school teachers and at least one physics prof who I very much respect who refuse to teach this equation. First of all, they argue it's redundant because you could use D equals VIT plus a half AT squared and average. And they don't like the fact that you sometimes lose some vectors. I haven't taught you how to square a vector. Let's do some examples. I have two big acronyms. I've already introduced DALP to you. DALP stands for Draw a Little Picture. The other acronym that I often use is DFIC. I say to students when in doubt, DFIC and DALP. And DFIC, it's just a mnemonic trick. It stands for list your data, find a formula, insert the numbers, and calculate or crunch the answer. Sam, that's not the end-all, be-all, one-size-fits-all problem-solving solution. What I'm really trying to do is to give students something to hang their hat on as a start. The only time I really get annoyed at a student is if they leave a question totally blank, because it means they didn't even bother listing the data. And then I kind of go, I don't know if you made a serious effort. So let's look at example 1. A dragster has an acceleration of 38 meters per second squared. I Googled these numbers. These numbers are fairly accurate. You're pulling right around 4 Gs in a dragster. It begins from rest. Often I underlined the phrase from rest because that almost always told us something. Sam, what's A asking me to find? So which variable is it asking me to find? I think the acceleration is 38. Yes. What's it asking me to find? I don't want to write out, this question is asking me to find the F. But I do want to make a note of that, so here is my notation. I write VF equals question mark. That's my shorthand notation for, that's what they're trying to ask me to find. Then what I do, Sam, is I go through the question and I'm looking for any numbers and any physics words. And what I really emphasized to my students last year, as much as I hate memorizing stuff, memorizing units is totally worth it. What's that 38? Even if it hadn't put that word there, I would have seen the meters per second squared and I would have said, I've memorized that that's acceleration. So A equals 38. Sam, from rest, what's that tell me? VI is 0. What's that 2.1? I'm looking for an equation that has a VF, an A, a VI, and a T in it. There is one. Gabe is technically correct, but he wasted my time. I did it again! Ethan, what am I doing, Ethan?
VF equals
See, Ethan initially said VF equals VI plus 18, and I will not take marks off if you say that, but I do want you to be aware of zeros, and if I'm really lazy, I can just say, look, I know it's VF equals VI plus AT, but since VI is 0, I can just go straight to that. Where A is 38, sorry, Ethan. I think I can do this in my head. 38 times 2, 80 times 2 is 80. 40 times 2 is 80. 38 times 2 is going to be 76. It's going to be 76 plus 3.1. 79.1, double check me. 79.8? 7.8. Golly. Units. And that's the other reason I've asked you, I say it's worth memorizing units, is that's kind of your closing, check the units. And then I often put a box around a question when I've solved it. You don't have to, but that's my touchdown dance. B. Nick, what's B asking me to find? It is. What's the time value in B? What was the time value in A? You know what? This is the same situation, so I'm not going to bother re-deficking everything. I'm just going to say D equals question mark. If it was a new time value, I would relist the data that I was allowed to use, but since it's the same time value, everything's fair game. Hey, I'm looking for an equation that's got a D in it, and it can have a VF and a VI and a T. In Physics 11, I taught you to avoid using a value that you'd calculated and find another value with that. We're big boys and girls now. I think whichever way is shortest is what I'm going to typically fall on. And if that means using a value that I calculated, I'll do that. Ethan, yeah? Often, instead of writing a half AT squared, I would occasionally write AT squared over 2. Is that the same as 1/2 AT squared? But I think that looks prettier. And that was easier to do some math with later on. So if you're wondering why I did that. A is 38. T is 2.1 squared over 2. 2.1 squared is 4 divided by, roughly, divided by 2 is 2. This is going to be really close to 2 times 38. So it's going to be really close to 80. I'm going to go 81, 82. Let's crunch it. If I can't get to 3 sig figs, then I didn't do it in my head. I can't believe I botched A. 83.8. Units, meters. Chloe, what's C asking me to find? How long is a bad phrase? And I picked it on purpose because it is ambiguous and you'll see it sometimes. Because how long is the football field can refer to a distance or a length. How long did the movie last can refer to a time. And so the phrase how long, you'll have to read the rest of the question and get the context of the question to figure it out. I do agree with you absolutely, Chloe. Time. I think this is a new situation. I don't think this is 2.1 seconds because it wouldn't make sense to ask me time and have the answer be 2.1 seconds. So I'm going to relist the data that I can use. I think I can still say that VI was 0. I think I can still say that A was 38. Again, for those that haven't had me before, Graham, I tend to check the units to make sure they all match as I list my data, but I rarely write the units next to my listed data because I found my writing is so atrocious and hideous it clutters things up. If you want to put the units next to your numbers, you can. I don't know whether Mr. Kamosi emphasized putting units there or not. I just never do. But what I did do is I made sure that that was the correct SI units. I made sure that it was 2.1 seconds and not minutes or hours. I didn't have to do a conversion. I checked that as well. So I tend not to put units there. Chloe, what's that 126? Looking for an equation that has a T, a VI, an A, and a VF in it. There is one. Can you get the T by itself, please? Now, VI is 0. If you hadn't bothered reading that, I wouldn't freak out, but I won't bother typing it. So it's going to be 126 divided by 38. 120 divided by 40 would be 3. It's going to be a little more than 3. Ooh, there's a 7. Yuck. I'm getting a repeating yucky. 3.2 something. I got. You know what? If I can't get it to 3 sig figs, I didn't do it in my head. 3.32. And time, seconds. Oh, there's a 19 in the denominator. That's why it was so ugly. Graham, what's D asking me to find?
Distance.
Okay. Can I use a time of 3.32 seconds? Yeah? Why not?
It's not in the equation.
Well, not just that. If that was the time, this wouldn't say 153. This would say 126. Right? And I can't use the 2.1. Okay, what can I use? I can still say we started at rest. I can still say A was 38. And what's that 153?
Yeah.
Looking for an equation that has a VF, a VI, an A, and a D in it. There is one. We already have time? Good catch.
D equals VF squared over 2A.
D equals VF squared over 2A. VF squared minus VI squared all over 2A, but Graham was lazy and said, I know that VI is 0. Okay. This is why Mr. Camozzi and I pushed the formula manipulation so much last year. If you were someone last year who kept stubbornly plugging in numbers and resisted the formula manipulation approach, I'll break you this year. I will convince you that algebra is far better than numbers, so I'm going to sway you over if I can. It's going to be 38 squared divided by... No. 153 squared divided by 2 times 38. Graham, is this a fraction? Is this a fraction?
Yes.
Is there more than one number on the top? I don't need brackets around the top. Is there more than one thing in the bottom? I need brackets around the bottom. 2 times 38. You get 308 meters? Or am I wrong? Am I right? Yeah? Yeah? Kind of giving you a rough... Any of you been to a drag race before? I know there's that course in Mission, but I've never been, and I really should as a physics teacher. In question C, 126 meters per second is roughly 60 miles an hour. So you're roughly doing 0 to 60 in 3.3 seconds-ish. Suppose the dragster hits a top speed of 162 and we pull the chute. A, you know what? Since it's a part A, I'm going to write a little A. If it takes 12 seconds for the dragster to come to a stop, what's its average acceleration? Good stretch, Trev? Excellent. Trevor, what's A asking me to find? Yeah. What word did I put in front of the word acceleration? You're going to see I do that fairly often. I'm hedging my bets. I'm betting in real life, Trevor, that the acceleration isn't constant. When I jumped out of an airplane, when I jumped out of an airplane and pulled the parachute, the initial yank was much more severe than the rest of the slowdown, and I suspect that's the case for a dragster. Jacob, we don't have the math skills to handle that. You need calculus. So if you ever see me putting the word average in front of something, I'm probably saying, you know what, I don't think it's a constant acceleration, so I'll be a nitpicky physics teacher and say, actually, we're finding the average acceleration. So you're saying A wants us to find A, Trevor? What else do I know? What's that 162? VF? Which one? What's VF? Read carefully. What's V final? What is it? 0. Come to a stop. So VF is 0, which means VI is 162. What's that 12? Looking for an equation that has an A, a VF, a VI, and a T in it. There is one. Can you get the T by itself, please? The A by itself, please? Now, technically, you could argue, hey, Mr. Dueck, that VF is 0, but I often find students like to leave it there just to remind themselves that it's negative VI. I often find if kids cancel it out, they forget the negative, so I'll put it in there. It's going to be 0 minus 162 divided by... Trev, am I going to get a positive answer or a negative answer? Which is good. Why should I get a negative answer? Because I'm slowing down. That is a negative acceleration. So at first I was worried, but actually no, that confirms I probably set this up correctly. I can do this in my head. Divide by 2, divide by 2, it's going to be 81 over 3, which is going to be 27, 27 over 6 is what cancel out. 27 divided by 2, 13.5? Yeah. So you're averaging pulling about 1.5 Gs, a little less. Probably in real life, massive yank at the beginning, and near the end of your stop, you can hardly feel it, which is why I said average acceleration. That is kind of a quick review of the variations on the kinematics equations that we spent several weeks looking at last year. Time for another thought question. And once again, we're going to vote. So here's the question. An object starts at rest. I probably underline the phrase at rest. And it accelerates east at a constant rate. When it's traveled 10 meters, it's moving at a speed v. How fast will it be moving when it's traveled 20 meters? Here are your options. A, v. B, more than 2v. C, exactly 2v. D, less than 2v but more than v. Question, Hannah? Sure? You with me? Good. So again, here's the situation. After 10 meters, we're going v. When we've gone twice as far, are we still going v? Are we going more than twice as fast? Exactly twice as fast? Or faster, but less than twice as fast? Once again, you're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. So we have 4 choices. Who says, Mr. Dueck, after 20 meters, we're still going V, A, V, A, A, V, V, A, 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 V? Answer A. Got Maggie? 1? 2? 2? Okay. Who says B, Mr. Dueck? Can be more than twice as fast. More than twice as fast. 2. Exactly twice as fast, Mr. Dueck. Twice as far, twice as fast. 1, 2, 3, 4, 5, 6, 7, 8, 9. Faster, but not twice as fast. 1, 2, 3, 4, 5. Got a pretty good split here. On your unit tests, there is going to be, on almost every single test, a purely algebraic question like this. Your Q is, the phrase I use is, using principles of physics, right to explain. You can call them essay questions. They're not exactly essay. They're proofs. Now, for any proof, Grace, you can always make up reasonable numbers and just crunch the numbers and show me what answer is correct. In other words, if you wanted to, you could let the acceleration be 2 meters per second squared. In which case, after 10 meters, you could find how fast it was traveling. You could actually calculate it, probably using VF squared equals VI squared plus 2AD. You could find how fast it was traveling after 20 meters, and then you could see by comparing those two velocities which one matched that. And I will always give you full marks for that, but Jacob, let's try going algebraic here. I'm going to use this. Because there is a D and there is an A. I don't know what the A is, but it does say at a constant rate. Oh, you know what, though? I could have just done that, because VI is 0. So cross out VI squared plus. How would I get the VF by itself? Good. This is the equation that describes how fast you're going after a standing start, starting from rest. Okay. Where is the letter D inside the? Okay. Suppose I double it, which is what we did going from 10 to 20. Suppose I double it by just tucking a 2 in front there. Where is that 2 inside the? If I want to keep this equation balanced, I think after 20 meters, I'm not going to be going twice as fast. I'm going to be going root 2 as fast, which is faster, but not twice as fast. The correct answer is, where it says explain your answer, I just did. If you actually tried crunching numbers, you would notice, oh, if initially I was going 5 meters per second, afterwards I wasn't going 10 meters per second, I was going like 7.6. Faster, but less than twice as fast. And you would have said, oh, the answer is D. But I'm going to slowly nudge you, Nick, into the wonderful world of algebraic proofs. We'll practice them. There's actually some on your reviews. There's always going to be some in the homework. We'll start. This is also what I had in mind when Mr. Kamosi and I pushed formula manipulation last year to get you good at the algebra. What's your homework? You can circle 1, 2, 4, 6, 7, and 10. Let me do that right here. 1, 2, 4, 6, 7, 10. And then if you want to get a head start from the ultimate review, you're also now capable of doing those. That is not homework. That will be due the day of the test. But if you're someone who likes to whittle away at these things, you're capable of doing 2, 4, 6, 8. Oh, that's easy to remember. And 11, 13, 15, 17, 19, 29, 30. Okay. That's not bad. I was hoping to give you 20 minutes to work on the homework, and you're going to get 20 minutes and 38 seconds. Wow.